tree method for classification is nothing special, almost same. We just need to define another loss function. So previously for regression task, we use RSS function to assess your training performance, and using the RSS value, you choose the best tree model and so on, right? But for the classification, RSS is not good idea. So indeed, we want to minimize the error, number of misclassified data points. So let's say y hat I is the output of your algorithm, then you just need to minimize the number of misclassified data points. So here, this is the indicator function. This value is equal to 1 when the condition inside the indicator function is true, and this value is 0 when the condition is not true. So basically, this equation indicates the number of misclassified data points. Okay, so for classification task, you can use this number of misclassified data point as the loss function, and then you can find the best tree that minimize the error rate. Okay, and this is called 0-1 loss. This is very intuitive, and this is what we really want to minimize. We really want to minimize the number of misclassified nodes. But the problem is the 0-1 loss is not differential function. This is not differentiable. So sometimes this non-differentiable property becomes very tricky to train your machine learning process. And also sometimes it is very interesting when we can capture some similarity between classes. But with 0-1 loss function, maybe this is not a good idea, because this just indicates this is true or not. This does not capture how much close your decision output to the true label. If there is some similarity between two labels, maybe many errors will be located in the boundary between the similar classes. Okay, so when you just use 0-1 loss function, indeed you cannot capture such property pretty well, right? So many people invent another type of loss function. First of all, the loss function should be differentiable, because the one very major problem of 0-1 loss function was non-differential property. And also, the loss function use all other labels information, so that they can be some nice alternatives that can resolve some issues of 0-1 loss function. Okay. The first one I want to introduce, and in our textbook, is Gini loss function. Here the loss value is Qm times K12 capital K. Here capital K is the number of total classes. P hat mk 1 minus P hat mk M12 capital T, say. So here Qm indicate the how many data point belong to the M's area. Okay, so QM indicates some portion of your data point belong to M's area or M's region, and P hat MK indicate some kind of empirical class distribution in area M. So which can be defined like this. Okay. So when you look at this Gini index, it looks like P minus 1, P times 1 minus P, and it becomes maximized when P hat MK is equal to 1/2. If P hat MK, you can freely choose P and MK from 0 to 1. So for one single computation, this function, you can maximize this value with this 1/2. When you consider this entire portion, this is maximized roughly P hat MK is equal to 1 over capital K, because in the case you have constraint, the sum of P hat and K should be equal to 1. So basically this Gini index is maximized when P hat is almost equally distributed. And actually when the P hat value is equally distributed, then the area, the partition contains almost zero information. Any decision is not good choice because there's no majority. So that is kind of just random guessing, right? So when you have one area and you have all kind of different labels, what is the representative? What is a good function value for this area? There's no good function value. With any function value, you always have many misclassified data points. When you pick this one as the reference or representative label, then all these remaining data points will be misclassified, right? So as P hat equally distributed, your quality of output becomes worse. Okay, so Gini index is kind of a measure that can assess this kind of property. Okay, and entropy is another good measure, very similar. So how can we compute the entropy? This is minus some M12 capital T Q M times K12 capital K P hat MK log P hat MK. Like Gini index, the entropy also has high value when P hat equally distributed. So again, when your labels in one area is very spread, not concentrated one particular label, then with any choice of your decision or your representative data point or references, you cannot make good decision. So your quality, the current quality of the decision tree is pretty bad. Okay, so entropy also is a very nice measurement for your classification decision, which will explain the quality of your current decision tree for classification task. Okay, so these two are very popular choice of your classification loss function.